Oh, hello, hello. All here. Live camera. If not, I will wait until everyone. Isn't you don't want to fix your video camera, huh? Okay, ready? So we are done with the component of science called chemistry, biology. The first four chapters, biology, living things, animals, bacteria, viruses. And then we look at chemistry, water, acid, alkaline, three things we need. Now we move on to the third part, which is physics, right? Electricity, force, motion, right? So let's look at chapter 7. 对吗? Chapter 7? You're studying chapter 7, huh? All of you got your notes with you? Okay, so what is chapter 7 all about? Okay, chapter 7 is electricity. Give me a second. Okay, I have to turn off the volume a bit. So this chapter is all about electricity. What do we measure in electric? Any of you take RBT here? Anyone take RBT here? Yeah, almost a lot of you take RBT. Norfe is not here. So for those who are taking RBT, you learn maybe a little bit of electric before. I don't know whether you learn arus, voltan, rintangan, right? It's the same thing you're learning in RBT. RBT must take, some people take ASK, right? Asa size computer. So different students. So when you learn that in RBT, you learn that in science, same thing, repeat. Formula, everything, same, no difference. So you study one thing, you got two subjects, knowledge already. Is that good? Okay, except you just translate to Bahasa Melayu lah. Okay, so we can look at things like why when you rub the balloon on your head, your hair will attracted to the balloon. What is happening? Why is there lightning? How is lightning formed? Right? So we're going to go into all of this. And we're going to go into to measure electricity. There's electricity. How do we measure them? There's three things we need actually. Everything in this, everything from this part onwards, right? All talking about these three things we need. Okay, so it's just new concepts that you have to learn. This is a lot of calculation. And then finally, we learn about magnets. You all know what's a magnet, right? But do you know that magnets got a certain magnetic field? But do you know that electricity also can make magnet? Huh? What? I don't get it. So we're gonna see that magic. All right, when we reach to the end of this chapter. So let's start with the introduction of this 7.1. Now, what is 7.1? 7.1, we're gonna start from here onwards. This chapter, the next chapter, you learn a lot of this thing called energy. Lead, right? Energy. Now, what is energy? Let me ask you. If you got no energy, what will happen to you? If you got no energy, what will happen to you guys? Type in your answer. Tired. Correct or not? Tired. Can do work or not? Are you able to do work lying on the bed? Yeah, correct. Cannot do work. Exactly. So energy is your 能力, your ability to do work. That's all. You got no energy, you cannot do work. What is work? Lifting up my hand is work already. Pushing something is work already. So SI unit. Now, how do we measure energy? Can measurement energy cannot be seen one, Actually can. We can measure energy. And the unit, we have unit for it. All right, just like temperature, you got degrees Celsius. Length, you got meter. 你的重量 got kg. So SI unit for energy is joule. J. You've seen this before, the previous chapter. Food, when you calculate all the joule, it's just energy. Yeah? So what do you need energy for? To move, for your body process, 光合作用, light energy for photosynthesis. Okay? Cars, machine, all need energy, right? So we're going to go into the first law. Now, there's this law called thermodynamic. What is this? Not so much, it's actually energy, basically. Okay? Energy and heat. This first law of thermodynamics states that this thing, energy cannot be created nor destroy. Now, do you know what's the meaning of nor? Nor means cannot create, cannot destroy. Yeah, for example, light. Can you create light energy? Can or not? Are you able to create light energy? You cannot. Okay, you cannot make light. You cannot out of nowhere from your hand, boom, got light come out. Not possible. Then teacher, how about light bulb? Light bulb, what got light ma? I make light what? Well, let me ask you, do you know where this light come from? Do you know where the energy for light come from? It comes from this energy. So this energy is called light energy. The one that supplies light energy is electrical energy. So it's electric change to light. Not only light, it also comes out heat because you feel hot, right? So energy cannot create, you cannot just create light. You have to use a different energy to change it to a different form of energy. 明白吗? Yeah, you want electric in your house? Can I use the sunlight? Light energy change to electric. So you must change and change and change. So that's why the first law is you cannot create it, you cannot destroy light or heat. But if you want to have light, you can change it from a different form. I want light, I change from heat, for example, or I change from electric, for example. So that is how you get all this. Okay. Okay. So just now I gave you two examples. Oh, Norway, 9 o'clock, 9:09, 10 minutes late. Okay, just now I gave you two examples. Light, A3, heat, and what's the other one I gave you just now? Electric. 对吗? Yeah, they can change when depending on how you modify your machine. Now, this is only three. In this world, so far, there's a lot more. In this world, in your Form 2, we will learn other types, other forms of energy. How many are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. And to calculate all of this, there is a formula. But do you think you need to study this formula in Form 2? No need. Okay, if you go to physics, then you will learn the formula for all of them. If not, you do not need to. All right, so let's look at the many forms first. First, energy is given out by sun, light, bulb, fire, or light bulb and fire. This is light energy. Next, when you play musical instrument, this form, please highlight the word form. Be careful with this question when they ask you, tell me the change in forms. You know you're asking for this 8. Next, this is sound energy. Next, battery. A lot of people think battery is electrical energy. Not correct. Do you know how battery release electric out? You know how battery release electric out? There is another hidden energy inside. It is called chemical energy. Chemical energy. Now you know something new. Battery filled with chemical energy. Food is also chemical energy. Let's look at carbohydrates. Something you already learned before. Oh, okay, you learned before in primary school, is it? Or chair that can go faster, is it? Do I need, so no need to explain, I go faster. Okay, maybe explain a little bit faster for those who forget everything in primary school. So carbohydrates, okay, carbohydrates is filled with chemical energy. So that's why when you eat carbohydrates, you get the energy out from here. Yeah, fuel means petrol, diesel. Next, anything that move, 动力 or 动能 all right, this is called kinetic energy. Oh, you learned before, yeah, I remember. Heat energy is called what? 热 okay, heat energy. Next, energy that is released from radioactive metals, we call it nuclear energy. Next, this one. Okay, now these two, they are called a potential energy. But now you have learned two types of potential. First one, when I have, let's say, a rubber band, okay, let's say this thing, this elastic over here, all right, rubber band. When I put a stone in here, and then I drag this thing to the back, I drag this whole thing to the back. Now my stone is at the back here, all right? Now, when I let go of my hand, can this string go back? Correct? This string, this rubber band can go back to the original position. So when it can go back, that means there's some kind of energy hidden inside already. When you pull, you're actually transferring your energy to the rubber band. When you let go, the energy change. Now, this kind of energy that allows the rubber band to go front and back, this is called, let me use my red pen. This is called okay. What is ambil apa? All right, it's called elastic potential energy. Elastic means 弹性 all right, can bounce. Next, if you look at the stone over here, this stone, when I push the stone will fall down. A lot of students say, oh, because got gravity, gravity pull the thing. Now, when the thing move down, they start to have tongli, right? Kinetic energy, tonglang, kinetic energy. This energy must come from, remember, energy cannot be created. You must change from something else. There is this hidden energy inside. This hidden energy inside a high place object, we call it gravitational potential, gravitational potential energy. Okay, I will call this as EPE, and we'll call this as GPE. And lastly, you have electrical energy. A lot? Probably. But Form 2, not so much. They will ask maybe just a little bit here and there. All right, when you go Form 3, we will have a formula to calculate these ones and this one. When you go Form 4, Form 5, and all higher level, then you have other other formula for the rest. For now, introduction level only. Okay. Yeah, your poop and shit, that one all chemical energy, got heat energy inside. Now, just now, sir, just now was what? Just now was the forms of energy, correct? Now, look carefully here. Highlight the word sources of energy. Okay, now give me a second. I know the answer here, but I have to make sure I use back the same as your textbook because your textbook is your Bible, right? So sometimes I give the answer like solar, then your textbook would put the sun. So it's the same thing, but I have to be correct according to your textbook. So anyway, before we go further, okay, let's look at the source of energy. Do not confuse source and just now the 8 form. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 8 sources. What's the meaning of sources? Sources means where do I get my electric from? Where do I get my heat from? Okay, so write down first, underline first. Okay, getting the terminologies from your book. Give me a second. Okay, first one, this is easy. This first one is our source of energy is the sun. Right now. Okay. Next source of energy is chemicals in this. Whenever you see this kind of feature, you refer to e-book. Yeah, I'm looking at book. Let me know if I'm using something else different from the textbook. I'm scrolling the page. Give me a second. Yeah. I'm referring to the e-book a while. Because, right, sometimes students put solar is also correct. Yeah, but some teachers are very specific. They want the textbook was. So okay lah, yang give you bad textbook words. Okay, and so I happen to have your textbook with me. So anyway, this one is chemicals from radioactive substances. So radioactive substances. Okay, right now. Next up, this one. This one, you see all the jagung, this is actually a jagung tree, right? Now, plants, when they die already, right, we can take the leftover and we can generate heat energy from that. You decompose, you take the leaves, you put the bacteria, and then you start to produce a lot of heat. This is called biomass. Cannot lah. I don't know why my internet, when I needed it, it doesn't show. Okay, give me a second. Okay, next up, what is this? What energy is this? Anyone else? This is fossil fuel. That means you use fossil fuel. Example of fossil fuel, can you please write out examples? Petroleum. All right, natural gas. And coal, arang batu. Okay, got it. Fossil fuel, good. Next up, this is heat from the bottom of the earth. This is called geothermal. You learned geography before, right, Alice? Next up, this one. A lot of students put hydroelectric. It's actually correct. Okay, but we keep to water. So your source of energy is water. This one, your source of energy is wave. This one is the easiest, wind. So if you look back, what is this page all about? This page is all about where you get electricity from. You use wind to generate electric for you. Use wave to generate electricity. Water to generate electricity. This one generate electricity. Okay, this one burn to generate electricity. This one is to give you heat for cooking. Make cooking gas, you can use biomass. This one generate electricity. This also can use to generate electricity. You see? So these are your sources of energy. Understand? Sources means natural things around you. Done. Done already. Now let's move to proper electric over here. This chapter you study electric. You need a short break? No need? Can tahan? Yes, need. Walao, I just haven't started. Okay, I'll give you 2-3 minutes break. Come back by 9:23. Okay. No. Okay, I'll come back. 24 already. Hello, I'll come back. Come, turn on camera. All right. Maybe to make the class a bit more relaxing. Tomorrow, what paper you have? Exam? Maybe you can have Sejarah. Okay, maybe I make it the class lighter a bit so that you all can have some experiments later. Okay. So we will do some experiments together. So you all get ready. Later, I'll tell you what to get ready. So today we will learn of what we call this thing called electrostatic charges. Teacher, do quiz. No, we're going to do experiment. Okay, this one experiment only fun one. So let's see what is this thing called electrostatic charges. This is different from electric. Yeah. The next class we learn electric. We still have battery, and then got wire, right? Wire passing through the battery. Now, what you have is negative charges. They will move. They will move. That's why if I put a light bulb over here, they will make my light bulb light up. Okay, so this is called electricity. Electrostatic charges means the charge never move. The negative charge and positive charge, they stay there. So a lot of negative here, a lot of positive here, they will pull each other. You see? So that is why you have situation like second. Yeah. So you have situations like this. All right. Why does the balloon, when she pull up, the hair is attracted to it? Because one of them is very positive charge. Another one, which is a hair, for example, is very negative. So positive and negative, they attract each other. But the question is this: how did the balloon become very positive? How did the balloon suddenly become a lot of positive? And how did the hair become very negative? We must have done something first. And this something is very easy. It's just rubbing them together. Use the balloon, rub on your hair. Don't rub too hard, later pop, explode, I don't know. Okay, rub on your hair. And then when you rub the time, you will make one very positive, the other one very negative. So when you pull away, you get to see that a balloon attracts up there. This is called electrostatic. Yeah. So what is the meaning of electrostatic? The word static means non-moving. So there are electrostatic charges are charges that are static. What is the meaning of static? Not moving freely. Static means stay there. Okay. So again, like I asked you just now, how do you make electrostatic charges? You must two things together. Yeah, electrostatic charges are produced when two different objects are rubbed together. Rubbed together. Make sure you know this one. So when you rub together, then one part will be positive, one part will be negative, right? Okay, why is it like that? It's because the negative, so I show you, let's say this cloth over here, and this piece of ruler, you know, your plastic ruler over here, all right, balance equal amount, positive, negative, balance, neutral. But when you rub them together, these two rub together, and then the negative will jump from one to another. You see that? So the negative, we call this electrons. So highlight electrons, highlight transfer from one to another. So students, tell me, if my negative jump to the ruler, my piece of cloth now, my piece of cloth now, is it more positive or more negative? You see, it is more positive 了，对吗？ Then the negative jump to my ruler 了吗？ So my ruler becomes negative. Understand not? Yeah, so far so good. All right. So next up, I explained it. The next point is what I explained. You see, one object, they will lose electron. Now, remember, only negative can move. Positive 不可以动的啊, negative 可以动罢了. Negative can move only. So, when the object lose electron, electron is negative charge. So, if I ask you, you start to lose negative people from your life, you become more and more positive, 对吗? So, when you lose negative, you become positive charge. 明白吗? Understand? Next, if you gain electron, you keep taking negative things into you, then you will become negative charge. 明白吗? Electrons are negative. So you either take negative or give away negative. Understand? Can? So we look over here. Before rubbing, this is neutral. How I know neutral? Positive got 1, 2, 3, 4, 5. Negative got 1, 2, 3, 4, 5. So 5 positive, 5 negative. So we write here, this is neutral. This one, positive and negative balance. So we call them neutral as well. Understand? So, but look over here. After I rub the ruler and a piece of cloth together, tell me my cloth becomes negative, more negative or more positive? Look here. Do I have more negative or more positive? Can you see here? Do I have more negative or more positive? Hello? Wait. This is more negative mark. So this one become negatively charged. 明白吗? This one, I say it is positively charged. Why? Because 那个 negative 走了. Can? Yes, no? I move on. Who haven't finished type X? Okay, let's move to the next one. So if I have two positive things, let's say I rub this one, okay, I rub this one with the cloth 嘛，我变成 positive, 对吗? I use another stick, rub with the cloth, and then this stick will also become positive. If we put the two sticks together, will they attract or will they push each other away? What do you think? This two piece of ruler is positive. Positive, positive will attract or positive, positive will push each other away. Hello? Positive and positive will push or attract. Positive and positive actually push each other. Same, they will push. Opposite, they will attract. Understand? So we don't say push. We say same charges, we say repel. Same charges. Same means positive, positive. Understand? Opposite charge attract each other. Okay, so let's look over here. When the balloon is, I will use black color to show. When balloon is neutral, okay, neutral, same amount. Hair also neutral, but when you rub two things together, according to today's science concept, when you rub two things together, electron transfer will happen. So what happened? Electron transfer. So if you read here, electron transfer from where? From hair to balloon. That means, I'll go to my drawing, I'll remove the negative from the hair. The negative have gone into the balloon. You see? So my hair now is more positive. My balloon now is more negative. The more you rub, the more you charge. And because of this, positive will attract to the negative. Understand or not? Yeah? Now, this only works for non-metal. If you are a metal, you rub until tomorrow, you will not be able to charge the metal. Yeah? So this is only for non-metals. So let's do a simple, since we have time, let's take 10 minutes to do an experiment. All of you, can you take a piece of paper? Just take a piece of paper. Okay. Now, I want you to tear the paper into small pieces. This is too big. You look at my finger, so big, right? We tear smaller. So small that until it is this size. Even smaller than this is better. The smaller, the better. Okay? I'm gonna place on my table over here. Can you see? I'm going to tear this paper, put here. Everyone see that? All of you done? Those who have not done this step yet, type X. Who is still not here yet? So it's a very small size. All of you tear paper. Done? Yes, no? Who haven't done type X? Okay. Now, you have to do it yourself to believe it. Next thing. All of you got your plastic ruler? Can you show me your plastic ruler? I got no ruler. I'll take my house access card. Okay. I take my house access card. Next thing you need is a piece of cloth. Now, let me tell you what cloth is the best. Your school tie. Majority of you, your school tie is actually very good cloth. I'm going to use the t-shirt I wore just now. I realized just now the t-shirt I wore when I start the class. Notice I changed already. Okay, this one is like, it's not even cloth. This is like polyester. Like a bit sports jersey. Those who have sports jersey is very, very good. Any of you got PJK, baju PJK? Wow, lagi good. Okay, very, very good. Go and get. I give you 1 minute to go and find a cloth. Cotton, not so good. All this plasticky, your baju PJK, not cloth one. The Sentosa will be the yellow color, your yellow color shirt. Wash already. Okay, you find metal cannot. Metal cannot. You need plastic ruler or any plastic material. And you need a cloth. Your school tie is good. School tie is quite good. Sentosa school tie can try. Okay. Now, ladies and gentlemen, ready? I give you time. Okay, I give you 30 seconds. Go and hunt for them. Don't do anything first. Don't rub anything together, because you rub, then you start charging your ruler. We want to neutralize. Just mix it with air. Make sure it's dry. Make sure this thing is not wet. Make sure it's dry. Just flip until it's super dry. Okay. Hold on first. I got no ruler, so I'm using my house access card. Don't touch the paper. Leave the paper to dry. This one better dry. Down there, down also better is dry. Okay. All ready? Give me thumbs up if all of you are ready. Those who are ready, give me thumbs up. You can put on your tie. Yeah, Dylan also macam put on the tie. Norfei, found your object? Very rare we get to do experiments together. Let's try. Which tie, the gray one or what? Can lah, 青菜啦, school tie 都可以了啦. Okay. Now, look here. Okay. Now, where's the paper? Can I see? That paper over here. Yeah, let me open my screen. I cannot see my own screen. Pin. Okay. So, what I'm going to do next is, you see this paper here? First of all, look at this card, your ruler. You just don't touch, just put on top. Just lightly put on top. Put on top. Do you notice anything happen? Yes or no? Anything happen or not? Put on top. Okay, the answer is nothing should be happening first. Walao, teacher, you tricked me. Memang, okay, it's not supposed to have anything happen. Now, what I'm going to do is, I'm going to do a small little magic. Okay, gravity is pulling my paper down, correct? Is pulling my paper down, correct? What I want to do is, I want to find a special force, right, that can pull my paper up against gravity. Fight gravity. 可以咩? Can 咩? Can, students. You can do that. What we do is we take this ruler of yours and a piece of cloth. You are going to rub. Now, how long do I rub? A good 30 seconds. All right. The longer you rub, the better. A good 30 seconds. All of you start rubbing first. Now, next thing is, once you're done rubbing, immediately, now continue rubbing. Don't put first. I'm telling you first. Now you just continue rubbing. Just listen to me when I say. All right. Now, as you rub, after that, immediately take this card or your ruler, put very near. See, this is the paper. Put it, put it very, put it very near. Don't touch. When you touch the paper, it doesn't work already. You put it very near and notice what happens to this piece of paper. Does it jump to your ruler or does it not jump to your ruler? Okay, try that. So let's try together. Okay, maybe you can watch me first. Okay, it only works once only, I think. Okay, so I'm going to rub for a good 20 seconds. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and watch. Yeah, you see, I touch this now. Just now it jumped a little bit. Okay, let me try one more time. Okay. Do you notice this? All right, do you need some of them jump up to my card just now? This one was holding up just now. Do you manage to see that? So I want you to try. If you have a jumping paper up, type me. If you manage to jump it up, type me. There. Ta-da. All right. Yeah. Cannot there. All right. You can notice that it is hanging. It's not even going down. So this is called electrostatic force. All right. Those who manage, type me. So it has to be fast, and keep it warm. Okay, Dylan want jump up, me. Max also got me, all right? Yishin also, me. Yoma, wow, okay, Max showing his ruler already. Can. So rub like really fast and keep this, like, it's hot already, immediately put on top. You see the thing will jump up without even touching the paper. Yishin got it. Norfei? Please don't rub until the ruler patah, not my problem. Don't rub so hard also. Okay. I lost my part 断了. Yeah, teacher, I remember when I was small, I rubbed my plastic ruler with tissue. I put next to the tap water. Yes, it works as well. All of you? Zen Yi managed to get it or not? Zen Yi? No. Zen Yi, no. Okay, so you have to keep trying harder. Okay, later you can try. Jump a little. Okay, good. There's some proof there. Norfei, did your one jump? God, jump all the way to the moon. Okay, so what have you just experienced? Whatever you just learned just now. So let's explain what actually happened just now. Okay? Your paper happily, Morphe went off. Your paper happily being neutral. Happily being neutral down there. You, on the other hand, take your piece of ruler. Your ruler is also neutral. That means balance, positive, negative. And you take your piece of cloth. Your cloth is also neutral. Okay? So what happens when you rub these two together? You rub your cloth and your ruler together. Remember, according to electrostatic concept, when you rub together, electron transfer happens, right? So what does that mean? Okay, electron transfer from the cloth go to the ruler. Say, teacher, how I know cloth go, how I know, why must it be cloth go to ruler? Why cannot ruler go to the cloth? Actually, it really depends on what material you use. Some of you, this one jump here. Some of you, this one jump here. But it doesn't matter who jump where, because even if one jump, let's say this negative here, cloth jump to the ruler, this one will be positive, this one will be more negative. If ruler jump there, it will still be the same. This will be more positive, this will be more negative. Either way, both will be charged. 对吗? Now, let's just, yeah, everything is neutral unless you charge it, you rub them, okay? Now, ruler is very negative. That's why you rub. Very negative, right? You know what happens now? When you put your ruler, which is positive, but with a lot of negative, what will happen? This whole thing becomes negative, more powerful. So the negative is more powerful. More powerful, they will attract this positive here. These are this neutral. But because they are so powerful, they attract the piece of paper. All right, the positive will be attracted here, and the negative at the bottom. So it's so powerful that it attracts, pull the positive one upwards. You see that now? Yeah? So this force is called electrostatic force. Only happens if you rub objects together. Understand, ma? Can? Then just now you use your hand to stick on the paper and the paper stick onto your hand. Okay? Oh, that one different because my hand wet, ma. No, it's not. Yeah, my hand got sweat, ma. So you press on it, then it will stick on my sweat, lah. Okay? That one will be cohesive and adhesive force. Remember that? Ding, ding, ding. All right. Now, forget already. Exam finished already. Forget what is that. So, good. You have done your basic experiment. Actually, you know what's better or not? You can actually use the, you know, 恭喜发财, Chinese New Year, you have that Tupperware with the red color cap. You know, after you have done the red color cap, you keep all the cookies one. Correct or not? The plastic 可以看 transparent 透明的. Correct or not? All your Chinese New Year cookie. Wow, this Tupperware, I tell you, if you rub with the cloth, okay, and you put the papers on the floor, if you rub this Tupperware body, rub, you know what happens when you put nearby? They will just jump, pa, 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 pa. They will jump everywhere. Dylan, don't believe your brother Adam did this experiment last time. MCO, he has to make a video. He did this one. Correct or not? I still remember Adam's video. I still have it, I think. Yes, no? All right. So, very powerful. You can try that. He's not paying attention. Okay. Now, let's go to the next one. Can you see this part? Now, students, what is this thing? What is this? This is a device that you use in your science lab. It's called pronouns electroscope. Now, what is an electroscope? Electroscope is basically the purpose, right, to tell you whether the ruler you rubbed just now, did it become charged or not? Just whether got charged or got no charge only. You rub, whether it become positive charge, negative charge, whether it doesn't matter whether positive, negative, whether it is charged or not. So if no charge, this is what's going to happen. Nothing will happen. But if you put a charged item near the top head, whether it's positive, negative, it doesn't matter positive or negative. You get to see this thing, the lid will open up. Like, that's all. That is all. To detect whether got charged or not. So it is a device used to detect electrostatic charge. That is all. Okay. Now, we're going to give the parts a certain name now. The top part is called a metal cap. At the bottom here, the part that opens up is a gold leaf. What is a gold leaf? It's like a leaf like that, but it's a piece of gold. Please don't steal. Okay, it's not enough to make money from that. Yeah, no. Don't bother cracking open the electroscope. Okay, probably worth nothing. It's a very, very thin piece only. Okay, next. So when you put a neutral strip, nothing will happen. Near the metal cap, you see, the gold leaf doesn't open. we do not use open. Students, I'll teach you a new word. Open is called diverge. So in this case, go leaf does not diverge. However, if you put a charge strip, a strip means an object line in this case. Okay, strip means an object. Anything that you charge it, as long as it's charged, doesn't matter whether positive or negative. 总之 you put near the metal cap, you see the leaf opens up. So the gold leaf diverges because these two have become the same charge. I'll explain this much later. Don't worry, I'll explain this much later. Then, so you say, teacher, if I rub my ruler longer, rub for 1 good minute, wow, then your ruler becomes supercharged. You get to see the gold leaf will go out even further, not out from there, but maybe supposed to be from here, it goes up higher to here. So that's all. Super positive. Yeah. Why is it like erect? Why the gold leaf open up? Is it what you're trying to ask? Yes, very good question. We will get back to this in a while. Okay, let's go to the basic and finish up. Definitely, I will want to explain that to you because sometimes they can ask. So let's go here first. Let's see a real life rubbing. Now, when they rub, the charges will jump so strong, it creates a lightning. So let's see what is happening. Okay. Now, what happens? Why is there lightning? It's because of this. Cloud is filled with water. 对吗? When cloud move, is there any friction? You know it's friction or 摩擦力? Do they 摩擦 with anyone? They 摩擦 with the air, correct? Clouds and air, when they move, they rub against each other. And what have you learned in today's class? When two objects rub each other, electrons will jump from one to another. Correct? So imagine I am a cloud. Positive, negative, positive, negative, positive, negative. Let's say I'm neutral. When I move and I rub with the air, moving air, what happens is this moving air will transfer their electrons into my cloud. They collect a lot of negative charge at the bottom of the cloud. So imagine as you rub, all the negative jump and collect down here. Guys, remember, negative can move. What happens is this. When the cloud move closer to the ground, ground is neutral At first, ground is neutral 对吗? So negative here. Okay, I'm just going to draw neutral. But when the clouds move down a little bit, that means from up here, they move down. What happens is this negative will push away this negative. So this negative is like, oh yo, negative, I don't like you, bye-bye. This negative go down. And what will happen to the ground top now? It becomes positive. So the ground is filled with positive charge because the negative, bye-bye, 走了. And what happens now? Negative, they see, wow, so positive. They jump down. So this whole stream of negative charges strikes down, zap, hit the positive. So if you happen to stand here, they will hit you and then go down to the positive. Okay, you see that? So that's what lightning is. It's actually electrical charges, a stream of them zap down to the ground. 明白吗? Okay, so friction, please highlight friction, 摩擦. Then does it mean flash got a lot of electrons? I don't know. Superhero theory different already. Okay. Oh, that's why if your hair stands, it means there will be storm. Is he? Probably, yeah, probably, yeah. Sometimes, yes, good, So next time you use your hair to detect if there's a storm coming or not, right? You can be my weatherman already. So we don't need a meteorology already department. Correct or not? You don't you don't need to check on Google. Hey, today raining or what? Just look at my hair today. All right. Yeah, I think there's some truth to it. Yeah, sometimes, yes, definitely. So upper part of the cloud becomes positive charge, positively charged. The bottom part of the clouds become negatively charged. So the negative charge in the clouds attracted to the positive charge on the Earth's surface. What happened? Attracted means they zap down. Zip. If you stand there, gone. All right. Okay, this again form 2 fact, but there's a lot of more other theories as well. This is one of them. Now, done. Let's move on to the next one. So because of this, we need safety measure, some protection, right? Because if the clouds are nearby the buildings, the negative will jump and destroy the building. So to prevent that, to prevent this thing from attacking anywhere they like, what I do is I put a lure, I put a metal over here. I say, hey, cloud, hey, electrons, I put something very attractive over here. So this metal here will purposely attract, because if the lightning strikes, it will not strike here. It will strike this thing first. And this lightning rod here will conduct the electricity go down to the ground. Okay, so it doesn't damage the buildings. Understand? So what do we install? Lightning rods are installed on the buildings. Every condominium, every building will have lightning rods. Even KL Tower has that. Even KL Tower has that thing on top. Correct or not? All these are to attract the electricity inwards to them. Yeah, so that it doesn't attack the building. Next, so this is a provide a path for what? Electrons to move. Move where? Move to the ground. What happens when you go to the ground? We say we earth them. That means put them in the ground, earth them. So this prevents lightning from damaging buildings. So far, so good. Can? But what if the lightning did not strike exactly on the rod? Oh no. Now, electricity, they move based on what we call resistance. Yeah, that lightning rod provides the path of least resistance. So if the electric were to enter, the rod is very easy. It will start to absorb. Even if you don't want, the electricity will straight away enter that one. Electricity will follow the path of least resistance. Yeah. Okay, next thing. If there is a thunderstorm and you're stuck, do I run out under the tree, or do I go to the padang? Do I hide if there's no building? Do I hide next to the car? Do I get out from the car, or do I stay in the car? Will the lightning hit my car and explode my car? Have you ever heard of lightning cases and striking the car and cause the car to explode? Don't have, Why is that so? Now, car forms a metal cage. When lightning hits the car, you are inside. What is this creature? Some kind of like worm over here. All right. So this worm driving Shrek. Okay. So when lightning hits, the metal will conduct Elmo friend. All right. The metal will conduct the electricity down to the ground. You don't even feel anything. If the lightning hit your car, so you wouldn't notice, because the electricity would have conducted down. therefore protecting you. Now, this metal cage protecting you, scientists give it a special name. They call this pronouns Faraday's cage. Okay, it channels the electric current to the ground. Faraday is named after the scientist Michael Faraday, I think. Okay, so let me show you a real life Faraday cage. Okay, let's watch a video. See, today class, just relax, just watch videos, just do some experiment. While waiting, you can try rubbing the ruler again. Yeah, why is my internet so slow today? Okay, students, look at the screen right here. Now, what is happening? Can you see your screen here? Okay, so teacher share sound, Tesla. All right, so what's happening here is this machine over here, we're going to learn next week, okay? This machine is to generate electricity. Okay, they generate a lot of electric charge until if an electric charge build up so much, what will happen is they will jump from metal to metal. Remember, they're attracted to metals. So given plastic, they wouldn't jump to the wall and all because it doesn't conduct the electricity for them. So metals conduct electricity. So they will jump from here and go to the metal. Inside there, just to prove to you, they put a human inside. Will the human die? Let's hope not. Let's see. But if you touch the metal, then of course GG lah. Sorry lah, if you touch the metal. Okay, guys, you're watching real electricity. This is not animation, okay? That is how much electric is jumping from that coil to the cage, the Faraday's cage. Okay, any of you dare to sit inside there? Any of you dare to sit inside? Hey, I got played before simulating in the science lab. Yeah, you want to try. Wow, you're very what I remember Mr. Bean touching the thing, his hair stand. Oh, that's a different thing. That's what we learn next week. Okay, then when he walks his body track. Okay. So some of you really daring, all of you, some of you want to sit inside there. Okay, so there you go. I think the exact one more thing. All right. Sounds fun, I really want to sit. What happens if you touch the metal? I think it should be fine. I have to check again. I think it's fine because your body versus the neighboring metal, they will zap through the metal instead of touching your body. Yeah, like you said, your body has higher resistance. You're fighting back the electricity, so the electric don't like. They prefer to go somewhere which is easier to flow. Yeah. There you go. Okay, that is a Faraday's cage, just to show you. Wow, I thought electric was fake. There you have it lah. Now you see. Okay, you can see the effect of electricity. All right, can Now, 10:03. Let's see what else. Okay, so what is this thing? This one is what we call a Van de Graaff generator. It is very similar to just now that machine, the ZAP machine, very similar. Now, question is, how do they create electricity? How do they make electron jump? I don't know if you watched before the Mr. Bean episode where Mr. Bean touched that thing and then his whole hair stand up. Yes, no? No, 没有看过. 没有看过. Okay, I explain the science first and then only let me try to find that episode, then we can more relaxing class here. So let's look. This generator is called a Van der Graaf generator. Everyone say Van der Graaf. Okay, now what is it generating? It is generating means creating a high electrostatic voltage. Electrostatic means what? Very positive charge or very negative charge and stay there, right? So if you notice over here, Van der Graaf is made like this. You have take a highlighter, rubber belt, highlight rubber belt. Rubber belt. Okay. Now, what happens is this rubber belt, when you turn on, this rubber belt go like that, move. They'll go round and round and round. Now, as they go round and round, actually not shown here, is another piece that is touching, another rubber touching this piece of rubber. So imagine like your escalator like that, right? Keeps moving, but your hand keep touching the escalator handle. So it's rubbing each other, correct? So what happens is, okay, at first it is neutral. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so here got another touch, down there got another touch. So what happens when you touch, they rub, right? This piece will rub on this moving motor. What happens is you will start to pull the negative charge, because negative can move, they will be attracted into the rubber and will be moved out. So after some time, more and more negative will leave. Negative will leave, go away, left a head which is super positive. The longer you turn on the motor, the more positive it becomes. All the negative go away already. Okay? And then what happens when you put your hand, let's say, okay, you put your hand and you touch this object. Okay, now when you touch this object, your body is neutral at first. Okay, let me draw your body. Your body is neutral. Okay, let me just draw you with your hair. You have your hair here. I don't know what hair is this, but let's just imagine this is your hair. Okay, so don't laugh at my $1 million drawing. So this is your body, neutral. So I will balance every positive with a negative. It's ball. All right. So Demon Slayer, not Demon Slayer, my drawing. Now, when you touch it, students, what do you think will happen to your negative when you touch a very positive object? All the negative will move, will be saying, oi, 这里很 positive. So what happened? They will move, 对吗? All the negative will leave your body and go to this part. Yes or no? True? Right? So now imagine I remove the negative from your body. What do you think will happen? Your hair will be filled with positive and positive, correct? Because all negative your hair go away. So what happens? Positive, they will push each other away. So it will cause your hair to stand up, okay, and go different direction because they're pushing each other away. So that is what a Van der Graaf does. Okay, it will pull all the negative from you, make you very, very positive. Understand, ma? Yeah. So how do I know? Go and find Mr. Bean. Yeah. Wait, what's the time now? Still got time. Okay. So what happens if you put this machine, which is called galvanometer, you start to see over here, very positive, I put wire through. What will happen is electric will flow. Electrons from the water pipe will flow and pass through. How I know? You put a galvanometer here. They will detect the needle flip that direction, means you know electricity is actually passing through inside. Understand? So what is the take-home lesson we learned today? we learned that electrostatic forces can only be produced if you rub two objects together. 对吗? When you rub two objects together, one will be positive charge, one will be negative charge. Can? So, just to show you, simple one first. Let's not use Mr. Bean. Okay.
Nivea Extra Brightening 蕴含50倍维他命 C， 可深层修复肌肤，只需5天。
Try this one out on it's here.
Right.
The crank's going to turn the motor on the bottom, and when I turn it like this, you're going to actually start to feel some of the. Oh, do you feel that? There's a little. That's what happens here. You're going to get a nice little. Get a little closer. Oh, there you go. Isn't that a great one?
That's really
so, yeah,
cool.
You get a little farther away. You get a. So for every inch of spark, it's about 50,000 volts. So that was a thing is for sissies. So we're going to. You really can kind of build up those electrons, and that's what we're doing. This little electron elevator is sending the electrons to the top there, and it's jumping, so we get all this negative charge. And you feel it around, and so now you're going to start to feel the electricity flip some of the electrons this way. So if you go this way, these are just little pipe hands.
Where's the hand still not
It's a
standing?
mile away. You got to get out of there.
Oh wait, nah, there.
Okay, got the new Van de Graaff, and Riley's going to give us a demonstration of all the electrons going up into her head.
You're wearing a wig. It's not real.
All right. Two minutes, okay. Okay, don't laugh so much. Can you see this rubber belt over here? Okay, inside there's another pin in there. It's rubbing the belt and the pin, transferring the charges away, moving the charges away. Okay. Okay, guys, this is fake, okay? This is fake. Please, this is not true. All right, this is just a joke. Okay. What a silly show. Okay. I totally forgotten about the scene already. I thought he was attracting other things around here. I forgotten about the scene now that I remember. Hiyo. Okay. Anyway. There you have it. Some silly Mr. Bean stuff. Now let's go to latihan, guys. Okay, you do question 1, question 2, question 3, and question 4. Try your best if you can. If you cannot, it's okay. Question 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5 only. Try your best as many as you can do. Yeah, just fill in what is the source and so on and so forth. Can? All right, all good? All right, so for those taking exam tomorrow, I wish you all the best. I'll see you next week. Make sure you get your homework done. Yeah, if not, very hard because this chapter is quite difficult. All right, thank you, students.
Thank you, Dear Kenny. Bye-bye.
Thank you, Mr. Kenny. Bye-bye.